work out. Last time we were looking at different regions and identifying when we've got two sets, there are how many different regions within the Venn diagram?
3, 4.
4. Thank you.
4, yes.
Yeah. What we're looking at now is extending on what we were talking about, because we were saying, you know, within a Venn diagram, we've got one region, for instance, the first one. This region here is only in A. Remember that. This region here is only B. This region in the middle is both A and B. This region outside the circles is none of them, not A or B. But what we've got to do now is introduce you to the vocabulary, okay, and a new diagram. First off, though, we talk about union and intersection. Now, both of these diagrams look exactly the same at the moment because I haven't shaded in what we mean. Right. So, I'm going to shade in, and this is the kind of thing that you would be expected to do in an exam question, is shading in possible regions. So, if I have to shade in the union of A and B, yeah?
Would it be the middle one?
No.
What if they're united?
They are united. I know exactly why you're saying it. But what we're saying is we take A, set A, and set B and put them together. Alright? So we are allowed to put our element, or choose an element, however you want to think of it, in A or B, wherever we like. So actually, if I was to shade that, I would be shading in the whole thing. Okay? So, the union, therefore, we could say the union of A and B is A or B, we're saying. Okay, does that make sense? The union is quite an obvious one. But I do understand where it seems a bit kind of contradictory if you're saying the union is A and B together, so that means A and B, which means only the middle, but it doesn't. It's
Yeah, we're just saying A or B.
So the union of A and B means that you can put something in A or B. Yeah. Or both. I should say A or B or both. We should add that, shouldn't we? Because that's the middle region. Well, the middle region on its own, what do you think that's called?
Intersection.
The intersection.
Yeah, that's the one.
So we've got the intersection. Now another way of saying the intersection of A and B is to use
Both.
Yeah, it is in both A and in B. Okay. What's going on? I need a new one, don't I?
Are you an IC? Did you ever teach IC? Yeah, I feel well, yeah. How long have you had that there board marker thingy?
Too long now.
I had a feeling about IC.
Right, back in the room. So, intersection, okay, of A and B means A and B, okay? This pen changes colour halfway through. So A and B. So what we're saying is, if it can be in the intersection, it can be in A and B, okay? Right. Now we have some notation for those two. I'm not moving on to subset just yet. We have some notation, so we don't have to use words all the time. And this notation is this. So the union is A, funnily enough, a U, but without the line coming down, and B. I will get out of the way in a second. So that's A union B. Alright? So if you see those symbols, A with a U in the middle, it means union. It means you're allowed to select something from A or B or from both, depending on which way you're looking at it. Yes?
So you can't add the line with the U?
Yeah, why is it not?
Well, see that's a U, yeah, but it's not actually, that's not the notation, that it's just a nice curvy U. If you do, it doesn't matter. Right, don't worry about it if you have done. Right, intersection, just to keep things simple, what do you think it's going to be?
Oh,
It would make sense, AIB, but it's not. It's A upside down U. B.
That's because you talked about Alhambra. An N. There you go.
Really, more so than what happened earlier?
I was so confused.
Earlier.
And you put it at YouTube, Drius.
Okay,
So I don't know what that means.
so A union B is a U, that's the easy one to remember. A intersection B is that. So if you see that notation, and I say, right, this number belongs in A, that B, you know it has to go in that shaded region, in the middle, where it's in both. Okay? Right, now we're going to have a look. We've only really introduced two different diagrams, two circles overlapping. Now we've got to extend a little bit, and we were chatting over here about subsets, which means that if something is a subset, that everything of that set is also in the other one. Okay? So this diagram I've drawn here, I've said that B is a subset of A. So I could write that. B is a subset of A. So that says everything within that set is also in set A. There's nothing that's not in A as well. Okay? So what I should be able to say today in this room, I'm looking around, almost. I should be able to say that within my universal set of the classroom, there is a set of girls, which is set A, right? And set B is people wearing a tie.
Well, everybody is. Except for Allie.
Separate. So actually, wearing a tie is not a subset because actually there's one of you not in it. All right. But that's what we would be looking for. I could say set B would be people wearing shoes, but I just noticed quite a few of you have taken yours off, so that's also not. What about long hair?
Everybody's wearing a white shirt.
Everyone's wearing a white. Yeah, but I'm not in A. Why?
Because you're not a girl.
I would actually be outside the A. So that makes sense, doesn't it? So within set of girls. So B is a subset of A. There are actually two ways to do this as well. I'm going to ask you to do a bit of book research now. Alright? And it's to do with subsets. And there is two types of subset. Okay? There is a subset and there is a proper subset. Okay? One of them has notation that looks like this. It's like a C. It's like the U but on its side. And another one has like this. There's a line. Now, what I want you to do is have a look in your textbook. You can find the pages to do a Venn diagrams. I want you to see whether you can explain the difference between a subset or a proper subset, or which one has which notation. Make sense to you?
We shaded for every other one except for that. So are we not shading?
Well, we don't need to shade because B is a it's all things. What's more important for this one is what's just a subset and what does proper subset mean? Okay. Okay. You thought someone was supposed to explain? No? Would you like to?
You know.
So, basically then, I asked you to look at subsets and can I go on?
Substrate.
Yeah. Right, so subsets. Basically then, we've identified really that a subset is where you have one set inside another set. Okay? So, we've got set A and set B. So basically, we can say everything in set B is also in set A, yeah? What is going on?
Could you just use the back? Is the back the eraser? No, that. You see back of the pen?
It might, maybe, yeah.
No.
Yeah.
Oh.
Yeah, there you go. Right. So, there's two things there. So, have we identified that with a subset, everything in set B is also in set A? But that leads us to one more question. And that question is, okay, everything in set B is in set A, but is there anything else that's not in set B that is in set A? Alright?
It will be outside.
Well, that's the question we need to ask them. So, for instance, if I said to you, set A contains the following numbers. So that's supposed to be a curly bracket. 3, 4, 5, 6. Right? And if I tell you that set B is 3, 4, 5, 6.
This is. You just put it in B.
So, set B is 3, 4, 5, 6.
I get it. Yeah.
So, set B is a subset of A. But not only that, set B and set A are the same.
What? Yeah. If it was a different number, like if it was a 7, it would be in the A section.
Right, so then if I adjusted set A and added something that wasn't in set B, I would now have a number there. I don't know why. Have a question.
So, for instance, if it was like set A and B are within the same, but if it's now mine.
Go on.
Well, set B always have what they have in common.
So, like, if we say set B is a subset of A, yes, everything in B will be in A. Okay? So I will be saying set B is a subset of A. The question is there anything else that makes A bigger than B? Okay? So, is that sort of so for instance, I could extend A again and put another number 10 in. And 10 would be out here. Okay?
I get it.
Alright?
So it's like a bow. Yeah, it was in both because
Okay, so here's the thing. So we've basically got two situations. One where B is a subset of A, but there isn't anything else to make A different from B. And the other situation is where we say B is a subset of A, and A also has more in it that's not in B. Okay? So, what did we find? So in your book, page 58, apparently, it says, in the blue things, it says, A is a subset of B if all elements of A, so we've got the letters the other way around. I'll read it again, but with B and A transposed. B is a subset of A if all elements of B are also in A. That's what we've got here. Okay? We write that B is a subset of A. Right? But what that means is this situation here, where there's nothing extra. So basically we're saying that B and A are the same. So we could also say A is a subset of B, no?
No.
If they're the same thing,
Yeah.
I could basically draw A and B as the same circle, couldn't I?
Yeah.
If I got rid of that and just went, that's A and B, is that the same thing?
Yeah. But
Yeah.
then if it was
But with that diagram, I can't add anything else in. So that is this situation. So B is a subset of A, where B and A are actually the same thing, and that's where that second line comes in. The and, you've done these before, haven't you? Less than and equal to
Yeah.
is a subset and equal to. Makes sense? So if we have the situation though, we say a proper subset, which is what it says, if every element of B is in A,
So it'll just be C.
but they're not the same. So this situation, B is a proper subset, because if it's a subset, you expect there to be extra. All right? So the proper subset would be, put that circle back in, put B there, and then we'd have a couple of extra numbers as well.
Makes sense.
That make more sense now?
Yeah.
So B is a subset of A, but they're not equal. So we can say B and A are not equal. So that's why there's no line underneath the subset. So I guess if I were to draw the two different circles, just to finish this off before you pack away. Right? So if we have this situation where we have A and B, and let's say we have 3, 4 and 5. This one, there's nothing else here, so this would be B is a subset of A with the line.
Yeah, I understand.
Okay? If we have the subset again, but this time we have A and B, and we have 3, 4, 5, but then 6, 7. This one is where B is a subset of A, but it's not equal. Okay? Cool.